Somebody take multi-unit or multi-outlet assemblies, please. 230, John.
Multi-outlet assembly is defined in the NEC Article 100 as a type of surface, flush or freestanding raceway designed to hold conductors and receptacles assembled in the field or at a factory. The installation requirements are specified in NEC Article 380. Multi-outlet assemblies, as illustrated in figure 9.5, are similar to surface raceways and are designed to hold both conductors and devices. These assemblies offer a high degree of flexibility to an installation and are particularly suited to heavy use areas where many outlets are required or where there is a likelihood of changes in the installation requirements.
Okay, that's enough. Now let's look at figure 9.5 on page 232. And this is what we're talking about here. This is just like a trunk duct assembly. We had one in the shop here that we moved in the start of the semester. And these are modular. This fits your needs. You can put receptacles where need be in different types of receptacles. And this could be, the nice thing about this can be changed many times. So you'll be in a commercial facility, you know, for a month. They might have a printer of some sort. Okay, we're stopping production on that. Let's get rid of the printer. Let's put in a smelter. You know, and it's just all connecting to these trunk ducts. You can readily pull the wires in and out. You can readily change the receptacles. It's a nice permanent solution, but very modular. You know what I mean? It can kind of be reworked for what you need week by week, month by month, year by year. You're still keeping that same trunk and just changing receptacles or circuits in it. So it's nice and convenient to have. Loading allowance? Kyle, you back on track there?
Yeah, we're all good. The load allowance for a fixed multi-outlet assembly is specified in NEC 220.14H as 180 volt amperes for each 5 foot, 1.5 meters of assembly or fraction thereof when normal loading conditions exist. 180 volt amperes of each 1 foot, 300 millimeters of assembly or fraction thereof when heavy loading conditions exist. The usage in insurance office is expected to be intermittent, made up of only small appliances, thus would qualify for the allowable minimum of 180 volt amperes per 5 feet.
Okay, we'll stop there. You want to take receptacle wiring, sir? Agree?
Sure. The plans indicate that the receptacles to be mounted in the multi-outlet assembly must be spaced 18 inches, 450 millimeters apart. The receptacles may be connected in either of the arrangements shown in figure 9.7.
Okay, let's take a stop there. Let's look at figure 9.7. Have we ever seen any wiring done quite like this so far? Have you ever done anything quite like this? My answer would probably be no. All right. This is using one common neutral and having 3 separate hots coming out and feeding 3 different banks of receptacles, right? What problem do you see when things are wired like that? What are you seeing there that we just haven't done yet? Why is this practice a little different than ours? Why is this wiring a little different than ours? Phil, what do you think?
Because they're in series, not parallel, like they're not spliced in each.
No, they're in parallel. They're in parallel, that's for sure. Now I know what you might be thinking of. If you look at that first figure there, you see what looks to be 1, 2, 3, 4, 5 blacks feeding 5 receptacles in a row. Then you have, I would assume, 5 reds feeding another 5 receptacles in a row. Below it, they stagger. That's great, but what are we not talking about here? What else do you see there that's unusual?
3 phase? I don't know.
I think you're dancing around the point. Look at the neutral. Why is that one neutral wire for 3 separate circuits? Do we ever do that? Have we ever done that here or in residential wiring? If you're running a circuit for outlets, you're running a dedicated neutral for that circuit, right? So theoretically, wouldn't there have to be 3 neutrals here to get this job done? You would think, right? Because if we kept that neutral the same size as those hots, would that neutral be boiling by the time that those 3 circuits are at like their full load? If they're pulling like 18 amps, and that's 12 gauge neutral, that neutral is probably sizzling hot. It's probably melting the casing. If you're doing something like this, you have to upsize that neutral. But I would strongly caution you and encourage you to run a separate neutral for each circuit. Because if this neutral ever gets pulled off a terminal or that neutral fails, one circuit didn't get killed, 3 circuits just got killed, just because one wire failed. So know that this is code. Know that you have to upsize the neutral to fit the bill. Like if you're doing like 2 20 gauge circuit, that neutral should be like 10 gauge. You know what I mean? But I would strongly encourage you to never do it like this. Please run a separate neutral for each and every circuit that you do. Please, please, please. You will understand why that this is not a great method to use, how it's still code, but it's not a great method to utilize. Do you understand? Okay. All right, somebody take communication systems.
The installation of the telephone system in the commercial building will consist of 2 separate installations. The electrical contractor will install an empty conduit system according to the specifications for the commercial building in the locations indicated on the working drawings. In addition, the installation will meet the rules, regulations, and requirements of the communications company that will serve the building. When conduit system is complete, the electrical contractor, telephone installation company, and telephone company will install all cables and equipment for a complete telephone system.
Let's look at figure 9.8, and that's gonna be the raceway for that communication system. Nothing out of the realm, just using 3/4 EMT, all stuff you're familiar with already. Let's go to floor outlets. Sir? 235?
Yeah. In an area the size of the insurance office, it may be necessary to place equipment and desks where wall outlets are not available. Floor outlets are installed to provide the necessary electrical supply to such equipment. 2 methods can be used to provide the floor outlets. 1, installing underfloor raceway, or 2, installing floor boxes.
So floor outlets are gonna be very common if you have a huge building that has no internal walls, or very few internal walls. Especially if you have to put desks where need be. If you don't want any power drops, you're gonna have to do a floor receptacle. I really do not like to see them in houses. There's only a few situations I'll ever let that ride, but in commercial facilities, you see them quite often. And once again, that's just doing everything underground. It's you, the electrician, planning ahead before one wall is even up. You know what I mean? Normally they'll have like something like a foundation, something for you to go off of and measure off of. But you have to look at those building specs and see that, okay, this outlet is 24 feet from this wall and 55 feet from that wall. You have to go with string lines and figure out exactly where that box has to land. And you also know at what height that box has to come to. So there will be boxes as you look forward into here. There's gonna be boxes that you lay a base, and then there's a cylinder that comes up and you just cut the cylinder at a particular height that you need for the concrete, and then the cover seals it. You know what I mean? So there's a couple different methods for the floor boxes, but just know it's all underground. You know what I mean? Underground is definitely the hardest form of wiring and the hardest form of plumbing that I'm aware of. Usually you have no references, nothing is easy. You're digging everything through the dirt. You have to chalk your lines. You have to be sure of what other services are coming in there too. You know what I mean? If you're the electrician, you're first there in the site, and you start laying all your groundwork, and the plumber shows up 3 hours later and says, hey, my main has to be right fucking here. It's gotta be right fucking there. There's nothing you can do. So you're also encouraged that when you're doing underground, make sure the plumbers have already come and gone. It's way easier for us to move our shit than it is for them to move theirs. They have to be in a particular area. We usually have a little bit of flexibility. You know what I mean? Our lines will usually be on top of theirs. So please, if you're doing an underground building and the plumber has not arrived yet, you're probably gonna be in a world of trouble. You know what I mean? So yeah, underground is the hardest one. Does anybody have any questions about doing underground conduit lines or anything like that? Normally underground, you're gonna wanna go PVC, not EMT, right? Unless that EMT is gonna be within the concrete, but that concrete has to be above grade. If that concrete is below grade, everything's gotta be PVC underground. And 9 times out of 10, it's gonna be PVC anyway. It's just nice to work with. You can bend it, you can heat it. It's cheaper than running EMT. It's not gonna rust. It's easier to pull through. There's a lot of advantages. Continue with the underfloor raceway. Who's up? Phil?
The installation requirements for underfloor raceway are set forth in NEC Article 390. It is common for this type of raceway to be installed to provide both power and communication outlets in a dual duct system similar to the one shown in figure 9.9. The junction box is constructed so that the power and communication systems are always separated from each other. Service fittings are available for the outlets.
Why do we have to separate the power and the communication lines? What's the issue there? It's all electricity, right? Come on. Why can't we have those touching each other? Why don't you want to run data and power parallel to each other in long lengths? Disturbance, interference. Both two sides of the same coin. So that will happen, whether you're in residential, whether you're in commercial, it's going to happen. So just try to run them as sparingly as you can in parallel. Even perpendicular, you don't want to cross them too much. Always try to find a path that's isolated. Continue.
Floor boxes. Many types of floor boxes are available, including metal and non-metallic, poured in place and poked through. The exact type to be used is most often included in the specifications by the electrical designer. Floor boxes, either metallic or non-metallic, can be wired using any suitable raceway, such as rigid metal conduit, rigid non-metallic conduit, electrical metallic tubing, or electrical non-metallic tubing. These boxes, particularly those of the poke-through type, are wired with a cable wiring system, such as type MC. Some boxes must be installed to the correct height by adjusting the leveling screws before the concrete is poured, figure 9-11. One non-metallic box can be installed without adjustment and cut to the desired height after the concrete is poured, figures 9-12 and 9-13.
Okay, thank you. But just note, they say like these can be fed with MC. Let's think logically here. MC, if we're gonna feed one of these floor boxes with MC, you think it's gonna be on the first floor? Or it's probably gonna be second floor and above, right? You know what I mean? Because the first floor is 99.9% of the time gonna be concrete, right? Because that's the base of the commercial facility in which you are in. But the remaining floors, they may be concrete, they may be traditional lumber. You know what I mean? It all depends on what kind of a building you're in. So yeah, if you're dealing with traditional lumber, cool, run MC. Cool. But if it's gonna be like a poured floor for each level, it's gonna have to be done via conduit. Okay, that's just common sense. But look at the smorgasbord of boxes you have to choose from. There's a bazillion boxes for a bazillion different situations. You're not gonna know every one of these boxes, but you know who does? The guys at the supply house. When you go there, hey, I have this situation, this box has to be at this depth. I'm running this size wire. I'm running this size conduit. What do you think? Well, they'll pull something out of their hat. You guys aren't gonna be experts on product knowledge, that's their game. You have to be experts in how to install it, okay? Any questions on floor boxes, where we find them, why they're in use, and what we use to feed them? We're all good? Okay. Fire alarm system, 237, who's got me? Kyle, you got me?
Yep. A fire alarm system with a battery backup is specified for our commercial building. These systems are commonly required by the local building code. The system is considered a power limited fire alarm. System, and thus will be required to comply with NEC Article 760, Part 3.
Now, unless you're with a fire alarm crew, I highly doubt you guys will ever install these. Normally they're made by like people like from like Eaton or Honeywell. They're gonna be like proprietary systems that only their software is gonna work. So 9 times out of 10, you really can't do much to help these guys. You might help them pull wire. You might help them terminate fixtures. When it comes to the control work, the panel work, unless you're contracted for that job specifically, you probably will never touch it. All right, let's continue.
A control panel is installed in the owner's room in the basement, see figure 914. An annunciator is installed inside the back door near the stairways. Smoke detectors are located as required by the manufacturer for all 3 levels of the building. Pole stations are located near the elevator and near the exit doors and stairways on all floors. Strobe type enunciators are located as required by the manufacturer on all 3 floors. The specifications in Appendix A provide specific requirements for the fire alarm system.
Yeah, and those type of deals are gonna be everywhere. I mean, you can see them in all of our buildings and all the labs. It's gonna be pretty much standardized throughout the entire system. Both in the alarms, the strobes, and the exit signs are usually all tied into that fire system. Alright? Finish it off, Kyle.
These fire alarm systems formerly were required to be wired in continuous loop with no T-taps. In other words, there could be no branches from the detector or enunciator loop. The concern was that the fire alarm control panel could not monitor the branches from the detection or the enunciator wiring.
Alright, now why is that a problem? One continuous loop, right? Back in the day, all fire alarm systems were on one continuous loop. Just like most security alarms back in the day were on one continuous loop. What that means is every sensor that was on that system was normally closed. Normally closed, normally closed, normally closed. It could be 100 sensors. You could have 100 doors and windows, right? In a commercial building, easily, right? And if you put let's just talk about the alarm system because it's easier, like the burglary system. They both mean the same thing, but it's just easier to talk about. So let's say there's a sensor or a limit switch basically on each and every window and each and every door. So as soon as you open that door or open that window, the magnet inside just dropped and you changed that set of contacts from normally closed to open, right? Once it opens up, it kills power from that circuit, letting the alarm know, okay, we have a trip. And that's great. You know what I mean? Whether it be the burglar system, whether it be the fire alarm system, if one of those were to open, you drop power from that circuit, the control panel knows that there's an issue and it fires the alarm. Great. How could this be bad? Why is this not the best method? What's the issue with that? It just told you that there was an issue, right? Somebody just broke in. Okay, the alarm sounded. A fire just started. Okay, the alarm just sounded. Why is that a bad thing? How could that be any better? What if we had zones? If it's a 5-story building and the fire alarm just went off, do you have any fucking clue where that fire is? No, it's just gonna tell you that there is one there. Same thing with the burglary alarm. Somebody just smashed open a window on the 3rd floor. Great, the police are on their way. Do they have any idea where to start? No. It's gonna be zones. Like these control panels are a lot smarter than they were even 20 years ago. This is probably gonna be able to tell you which floor and in which section of the building this caused. Now, if you wanted to get really particular and have every single one go back, then that means every sensor is gonna be a home run back to that control board. And can you see how that's an issue too? You know what I mean? That's a lot of fucking wire coming back to one control. So 9 times out of 10, it's not gonna be one continuous loop for the entire building, but it will be sectioned off in zones. So if there is a problem, we'll know, okay, it's the 3rd floor and it's A wing. There's 3 wings, you know, A, B, C. 3rd floor, A wing. Is that precise? No, but is it a way better answer than just there is a problem? Okay, so just know why, you know, a continuous loop system works and it worked back in the past, but doesn't work today. We need to know a little bit more specifics. And do you see how running multiple lines back can give us a better picture as to what's going on with the building? All right, now we're gonna switch gears to panel board selection. It's gonna be located on page 260. You all there? Nicole, hit us with some objectives.
After studying this chapter, you should be able to identify the criteria for selecting a panel board. Correctly place and number circuits in a panel board, determine the correct overcurrent protection for a panel board, prepare a panel board directory, determine the appropriate working space about electrical equipment.
Go Beans. John, intro.
The installation of panel boards is always a part of new building construction such as the commercial building. After a building is occupied, some loads such as for more energy efficient lighting may reduce a load. Other modifications including adding new equipment, may cause electrical system demands to exceed the capacity of the installed system. In this case, the electrician is often expected not only to install new panel board, but also select a panel board that will satisfy the needs of the occupant.
I would argue that in a residential application, then yes, you are the one to say to the customer, I think you need this because of this reasons. However, in a commercial facility, they're probably gonna fucking tell you what they need. You know what I mean? There's probably an engineer who already spec this job out, you know, unless they're just looking for you to add like another panel box for like future work, it's probably gonna be something pretty specific. And it's probably gonna have a couple guys already in mind, like the engineer, it probably already went and got past like, you know, like when they wanted to get the permit for it, it had to go to their inspection group passed it because they think it's a good idea. So rarely are you just gonna go, I'm gonna put a panel box here, you know what I mean, in a commercial facility. Normally it's gonna be predetermined by somebody way higher up than you. You do have the ability, but that will probably be predetermined, okay? You wanna continue, sir?
Oh, me?
Yep.
Separate feeders are to be run from the main service equipment to each of the areas of the commercial building. See figure 8-1 for a graphical explanation of feeder conductors. Basically, they can be thought of as the conductors between the service and the distribution panel board, where the branch circuit breakers are located. Each feeder will terminate in a panel board, which generally will be installed in the area to be served. Figure 12-1 shows two types of typical panel boards. The first panel board has a main breaker plus many branch circuit breakers. The second panel board has a branch circuit breakers and only is referred to as the main lug only panel board, or MLO.
Okay. So, and this is a lot of great information just in that one paragraph there. So yes, would it make sense to bring a panel box, like, you know, like let's say, here, let's go on the board here. Now, when they say feeders are going to the panel boxes, they just mean the conductors feeding that panel box. And let's say I'm in a room that's 200 feet by 400 feet. And I just have all my panel boxes in this room right here. I have 4 panel boxes in the electrical room. And I have receptacles all in this wall. How long is that home run gonna be just for one circuit? 400 some feet just for an outlet. Does that make any sense at all? To consolidate all of your panel boxes in the electrical room? Is it easier for us to wire up these panel boxes? Hell yeah. You know what I mean? The main comes in, the meter's probably right outside the room. All the panel boxes are right there. It looks great. The room is well lit, nice and clean, no obstructions. But the money that you waste just getting copper from here to here is extraordinary. So it's going to be very common for you to have an electrical room with, say, 1 or 2 panel boxes, but other panels split up throughout the environment to better serve that environment. Now that wire run is way reduced going to here. Now the wire run to here is way reduced. Is it still a little long over here? Yeah, but one of that can grab there versus coming from here. So that's why we stagger panel boxes throughout the entire building. Just like the Naples. They have the one that we were working at Joey's house. It's an 800 amp service coming into the house. There's 2 panel boxes in the basement, 1 panel box on the first floor, and another panel box on the second floor. Could they have all been kept in the basement? Hell yeah. But with that home run, the amount of time, the amount of energy, the amount of material that we need to get each and every home run down there, we lose our shirts on the job. So that's just one more reason why we distribute panel boxes throughout the environment. And now when you take a look at these 2 pictures, what are you seeing? What is not like the other? What's the big difference there?
It's not like a main disconnect.
Mm-hmm. So when I see that main disconnect, I think main panel box. I'm not thinking sub panel, I'm thinking main. Because the only way you're gonna see that main disconnect is if it's on a main panel box or a main breaker. The one that you see on the right is main lug. or lug only. The same terminology is used for both. But that's just indicative of a sub panel. So when you see that main panel box, chances are the neutrals and the grounds are going to be bonded together. In that sub panel, the neutrals and grounds are definitely going to be isolated from one another. So as soon as you see those 3 lugs coming in with no main breaker, your first thought should be panel box. Or your first thought should be sub panel box. Not main, sub. Okay? Where we leave off?
Can we just continue?
Yeah, continue for one more.
A panel board is defined by the NEC as a single panel or group of panel units designed for assembly in the form of a single panel, including buses and automatic overcurrent devices, and equipped with or without switches for the control of the light, heat, or power circuits. Designed to be placed in the cabinet or cutout box placed in or against the wall, partition, or other support, and accessible only by the front.
All right, so now when you buy these, right, these are 3-phase commercial panel boards. They normally don't come with all the guts within. You're buying the enclosure and you're buying the guts separate. You can have enclosures that are 38 inches tall, you can have enclosures that are 46 inches tall, and you can get different guts compared on what you're actually going to be doing in that building. You know what I mean? Do you need 20 circuits? Do you need 40 circuits? Do you need 60? Do you need 80? You can change out the guts to figure out what you need to suit your bill. So just know that they never come, pretty much ever, come pre-installed, all put together. And now what I told you guys before in lab, when buildings get huge, and let's say like this building has, 20 panel boxes. Let's say it's a huge building. Well, then when you order that up from Square D might send them with the breakers already installed. Because like I said, you're not just gonna be going on a 20-story building and just throwing outlets where you think you want them. It's already predetermined. You're going off that schematic. Well, if that schematic was made, they could have just sent that schematic to the engineers at Square D, and they could have figured out exactly what breakers you need and put them exactly where you need them. So it's less work for you, and you can get your job done a little quicker. Just know that that is an option. Continue. As indicated. As indicated.
As indicated in the definition, panel boards are the busing and overcurrent devices. They are mounted in enclosures such as cabinets. The installation of cabinets is covered in NEC Article 312. This provides overlapping requirements as the general rules on the construction and installation of panel boards are in NEC Article 408.
Okay. So now we know a lot about panel boards already, and let's just make sure that we know what we're talking about here. Is the numbering. The numbering is going to be the same. The number is going to remain the same whether you're in a single phase panel box or a 3-phase panel box. The only thing that's going to change is going to be the color, right? So if you're in a single phase, and now guys don't normally get too crazy on color codes in a single phase like a residential box. The only thing they really care about is the color coming in. So like the black for line 1, red for line 2. Well, in here, this is supposed to shake down the same way. In reality, on numbers 1 and 2, you should have a black wire there, and lines 3 and 4, you should have a red wire there. Is it giving a dingy on that when you get to a residential panel? Absolutely not. But the color code for a 3-phase panel box, 2-way 3-phase, this is going to be required. But notice that these numbers, they all remain the same. So get used to knowing what numbers are going on the panel box. They always come from the top down. And just know the color code between single phase and 3-phase. And now that's gonna be 208 3-phase. 3-phase. The 3-phase 480 is gonna be the same thing, but it's gonna be brown, orange, and yellow. And the neutral is gonna be gray. But these numbers are always gonna remain the same. You read like a book. Top to bottom, left to right. And if you look at figure 12.4, if you're dealing with like a big panel box, that's how they get their, that's how they distribute. If you look at the front view, A, B, C, and you see the pins that latch to the bars on top. Bars 1, 2, 3 coming in, that's how the power drops down. That's how you get your black, your red, and your blue. There's 3 single legs coming down. Although you can't see it in the panel box, that's what it kind of looks like without the plastic and the protection being there. Those are those 3 bars going down the center. All right, somebody read numbering of circuits. James, I think you're up. 263, numbering of circuits.
Me?
Yep.
The number of overcurrent devices in a panel board is determined by the needs of the area being served. Using the Amish panel board as an example, there are 9 single pole circuits, 2 pole circuits, and 3 pole circuits. See figure 12.3 for a panel board circuit numbering scheme example. This shows total of 36 poles when using a 3-phase supply. The incremental number is 6, a pole for each. A pole for each of the 3 phases on both sides of the panel board. Panel boards with space for 42 poles are often installed with this, as this provides considerable flexibility for growth. Note that the numbering of the overcurrent devices continues with odd numbers on the left, even numbers on the right, irrespective of whether 1 pole, 2 pole, or 3 pole overcurrent devices are installed or created with handle ties. Neutral and equipment grounding conductor terminal bars are installed as needed or desired. Electrical distributors often standardize on sizes ratings of panel boards, so a 42 circuit panel board with a 200 ampere rating must be less expensive than one designed for 30 or 36 overcurrent devices.
I'm gonna draw something else for you guys. I don't know if we talked about this either. Okay, let me start off with an easy question. Where on here, and use the numbers, let's just worry about this side here, the odd number side. Where can I install the single pole breakers? John, what are your thoughts? Where can I install a single pole breaker on that panel box? Nothing's used. So where can I install a single pole breaker on that panel box?
Pretty much anywhere on there, right? Pretty much anywhere on there.
Anywhere. Perfect answer. Where can I install a double pole breaker on this panel box?
On the lower portion of it,
Can you clarify?
like, I'm only going off of what I've like seen, but it would usually start at like 13 and continue down to 19.
Okay. So it's my theory that I like to put like the biggest, like double poles, triple poles. I like to put them as close to the source of power as I can. So actually, I try to get them as close to the top as I can. Or depending on how it's hung. If like the terminals are on the bottom, I'll try to get it as low
Oh,
to
okay.
the terminals as I can. But that doesn't answer the question. Where can I actually install a double pole breaker on there? Phil, what do you think?
2 slots will have to be.
2 slots, absolutely. But is there a place that I can, put it, or can I put it anywhere? If I put it anywhere, am I gonna get 208 off of each of these? Absolutely. But it's going against code for me to install it, say here, right? If you're going with a double pole breaker, that double pole can only be on a black and red. Can only be on a black and red. Can only be on a black and red. And that remaining one, that blue, is left open for a single pole breaker. Okay, so when you're installing a double pole breaker in a 3-phase panel box, that double pole can only be on black and red. Now conversely, where can a 3-pole breaker go on here? A 3-phase breaker, where can that go on here? Well, could I put it right here?
No,
And it work? Well, who told me no? That's not very nice.
because like the way it goes into the breaker, it has to be in the specific order,
Why?
because of just the way it,
Ah, man, they're,
Is it because of the poles that it's pulling the current from? So like it would have to be 3 separate bars, kind of like they're staggered?
they are 3 separate bars.
Yeah. Well, I mean, but the,
You guys are so close, you're dancing right around the answer. Because if I hook this up here, right, you're actually supposed to hook it up, once again, it's gotta start with the black, it's gotta be black, red, and blue in that order, right? Boom. 1, 3, 5, 7, 9, 11, 13, 15, 17. Because if I put it here, am I getting 3-phase power? Yes. But if I hooked up a 3-phase motor to that, is now that gonna spin backwards? Yes, it will. Yes, it will, and that could be big problems. So when you're installing breakers, just to go back, just to review, I can put a 3-phase breaker right here, because it starts in the black, 13, 15, 17. I can put a double pole here. I can put a single there. And I can put 2 singles right, or 3 singles right there. That all passes code, because that 3-pole, it started with a black, the 2-pole started with a black. Between that 2-pole and 3-pole, that one free open one, hell yeah, I can put a single pole breaker in there if I want. In these first 3 ones, can I put single poles there if I want to? Yes. Single poles, anywhere. Double poles, has to start in the black. 3 poles, has to start in the black. And we now know the color code, right? We beat that into our brains already. So this should be pretty easy. Just know that this is how the breakers are only allowed to be. Any questions on that? Let's do panel board rating. Who's up?
I'll do Panel boards are available in various ratings, including 100, 200, 225, 40, 400, 600, and greater amperes. These ratings are determined by the current carrying capacity of the internal main bus. After the feeder capacity is determined, the panel board rating is selected in compliance with NEC 408, which has a rating not less than the load calculated in accordance to NEC Article 220.
Cool. And yeah, they come in a whole bunch of sizes and flavors, and it just makes sense, right? If this building was sectioned off, you know, if you had a panel board here, and this building is huge, this might be a 200. But for these small areas, the panel boards might only be hundreds. Or they might be oversized. It's very common, extremely common actually, for three-phase panel boxes to be oversized, because you never know what's gonna be coming into that building. Things change. So in my opinion, it's best not to just nail it right in the head to give you exactly what they need. Plan for the future. Always go big or go home. You know what I mean? Always go above the code minimums, as I keep on saying. So where those two single hundreds are, might not be a bad idea to upgrade them to 200. Might not be a bad idea, instead of a 400 amp service, make it a 600 amp service, because you never know what's going to be coming in the future. You always want to be ahead of yourself. It's easier to just add on instead of reworking these panel boxes, pulling new lines. Big pain in the ass. Panel board overcurrent protection. Who's up?
Figures 12.5, 12.6, 12.7, and 12.8 are variations for providing overcurrent protection for panel boards. Two extremely important requirements must be followed regarding overcurrent protection for panel boards. Overcurrent protection for a panel board must not exceed the rating of a panel board NEC 408-30.
That just makes sense, guys. You wouldn't want to stuff 10 pounds of shit in a 5-pound pail, would you? You know what I mean? You wouldn't want to put 300 amps into a panel box that can only take 100 amps, right? That's just common sense. Continue.
Overcurrent protection for a panel board is permitted to be located in the panel board or at any point on the supply side of the panel board.
So what that means is that breaker can be in the panel board itself, or a disconnect can be put on the supply line itself. So the conduit feeding that breaker, normally you want to have it in sight. You know what I mean? You don't want to have that disconnect 8 miles away from the panel box. You hit the disconnect, you don't know what happened. You know what I mean? It's nice to have disconnect for panel board A, and then seeing panel board A right next to it. It's always a comforting feeling. Always try to have it within line of sight. Let's get panel board cabinet sizing on page 266. Kyle, I think you're up.
Because there are special requirements for using the wiring gutters on a panel board, the physical size of the cabinet is required to be sufficient to accommodate those requirements. Often a feeder serves 2 or more panel boards, in which case either a junction box or wireway is installed, or the feeder connects to the first panel board and is then extended to the others. In some cases, double lugs are installed for the phase conductors and neutral if used. Other designs have feed-through lugs with supply-side feeder conductors connected to the line terminals of the first panel board, and conductors of the same size connected from the load terminals of the first panel board to the line terminals of the second panel board.
So what are they talking about there? Double lugs, right? Is that like a really good band name? Double lugs? Like, I think that would be like a pretty good hard rock group. Nothing? Nothing? Come on. That joke was gold. Anyway. If you guys remember down in HVAC, there are 3 panel boxes on the ass end of the building. They're a 400 amp service. And I believe the first one is being fed from underground, if I remember this correctly. Between the panel boxes, there's 2 pieces of 4-inch conduit, if I remember correctly. Now, the main breaker is right here, and this is a 400 amp main breaker. Lines come up to there, and they come out of the top. If we look at let's flip back to page 261 here for a quick minute. And let's take a look at the picture at the bottom. And let's look at the one on the right, okay? You see the terminals coming in through the top, right? Let's envision, or actually let's take a look at the one on the left, all right? You see that main breaker on the top of it? Let's envision another 3 terminals, but at the very bottom of that panel box, all right? So you have the 3 terminals coming in for that breaker, and that's great. That breaker supplies power to the whole system. And at the bottom, you have those 3 lines going down, and they're supplying power to that entire panel board. And at the bottom, you have another 3 lugs, all right? Those 3 lugs, in reality, are actually taking power, and they're feeding it to another panel. Now in this box here, let's say that this is going to be a sub panel, so it's going to look a lot like the one on the right. The one on the right will actually be flipped upside down because the terminals are going to be on the bottom. But if you can just envision, instead of seeing 3 singular terminals there, it'll actually be 3 double terminals. They have 2 screws on it versus 1. The double terminal just means that one could, like, you have your line coming in, and you also have another line going out on each of them. So in reality, this is your shutoff, this is your main breaker. And at the bottom or the top, you have an extra set of lugs to continue that service, because this is a 400 amp service, right? If you wanted just this panel box to be able to take care of what everything can do, this panel box would be 10 feet tall to be able to fit all the circuits in. So we'll use these sub panels just to give us more room. And these double lugs will keep on extending that same power, the same 400 amp max current to all 3. So that's what they're talking about when they say double lugs, triple lugs. That's what they're talking about. It's just a way to jump off to another panel box that's right there. You know what I mean? Right on that same circuit, controlled by just one master disconnect that takes care of everything. Okay, so that's what they mean. That's what they're talking about, double lugs. Any questions on that, guys? Okay, panel board directory, 266. I think you're up.
One of the final actions in installing an electrical circuit or system is to update or create the panel board directory. A holder for the directory will be located on the inside of the panel board door. Some directories are a part of the informational nomenclature that is provided by the panel board manufacturer. The size and shape of these holders may vary.
And all they're getting at is you just have to note what circuits are doing what. And it's all going to be numbered. They prefer it to be typed out. You know what I mean? Just go in like Microsoft Excel, type it out just so it's clear as crystal, easy to read. Normally in residential panels, the cover is going to be literally sticked onto the side of the cover. You know, like 2 and 4 stove. You know, it goes on. And normally your house doesn't get reworked very often, if ever. So 2 and 4 will probably be stove for its entire life. However, on the commercial 3-phase mailbox, that thing is going to be getting reworked constantly. So we never just put a stick on the side of it, because in about a year, every one of those are going to be wrong. So that's why it's always printed out. And if you do any updates to it, you reprint it and then reflect your updates on that new card. Put the new card in there. Another electrician comes in a couple months, does some work, okay. Whatever circuits you changed, you have to note that on the plan. Reprint it, whatever. But just know that in a commercial panel box, they're never just stuck onto the side of the panel box. They're always going to be in a sheet on the door. Okay. Nicole, you want to take circuit directory or circuit identification?
Sure.
267.
NEC 408 is very clear as to its requirements for preparing a circuit directory. Every circuit and circuit modification shall be legibly identified as to its clear, evident, and specific purpose or use. The identification shall include significant or sufficient detail to allow each circuit to be distinguished from all others. Spare positions that contain unused overcurrent devices or switches that shall be described accordingly.
Let me just stop you right there. Yeah, and also in residential panel boxes, it's not very common at all to have spares. But in commercial ones, it's very, very, very common to leave spare breakers handy. Like down in HVAC, there's half of them are spares. But you just have to note that they are spare breakers. And just putting spare is usually enough. Okay, continue.
The identification shall be included in the circuit directory that is located on the face or inside of the panel board in the case of a panel board and located at each switch on a switchboard. No circuit shall be described in a manner that depends on transient conditions of occupancy. Alright, continue. Table 12.
No, you're good, you're good.
Oh,
You're good.
right.
Let's take identification of branch circuits and feeders.
NEC 210.5C requires that where more than one system voltage is used for premise wiring, all panel boards and similar branch circuit distribution equipment shall be permanently marked to inform persons working on the equipment of the system voltages of how the underground phase conductors are color coded. This requirement includes panel boards, motor controllers, switchboards, and similar electrical equipment.
Yeah, so you really have to know like what kind of power is going into that panel box. You know, like caution 208 3-phase. Or more common, you really want to label, I mean, you pretty much know it's going to be a 208 3-phase panel just by popping it up and looking at the colors. But you really want to know if there is a high leg in use. And we talked about high legs before, we know what they are, right? High legs. Nicole, high legs? I'm like an artist today. Terrible artist, nonetheless. All right, so here's your panel box. You have 3 lines coming in. Line 1 could be 120 volts. Line 2 can be 120. When you put them together, that's your 208 2-pole. However, this last leg here could be 277, and that could be our high leg. Now you see this configuration a lot, or that could be 277. It could also, I've seen 240. I think 277 would be a little more common. But this is a high leg panel box, which means that 1, 3, 5. So that means that for every, when you go in 3, you're gonna have 2 120s and 1 277, 2 120s and 1 277. So it sets it up nicely. So if you still have to run like medium-sized stuff like a range, a water heater, air conditioning, right? Something that doesn't require 3-phase power, but 2-pole power would be pretty nice to run. You can still run it. You can still get your 208 2-pole off of breaker 1 and 3. But breaker 5, you get 277 volts to ground off of that. And that could be nice if you're running a lot of lights. You know what I mean? A commercial facility, like think of Johnson College. What do you think the vast majority of our electric bill is? It's probably lighting. You know what I mean? It's probably actually 60% lighting, I would probably argue. And we know that the higher the volts, the lower the amps. You pay by the amp or the kilowatt hour. So wouldn't it be making more sense to have your continuous load, your heavy usage lighting off of 277 so you can be drawing less amps? Absolutely. And that's why this is commonly done. So you still have your 120 to run all your lights, or not your lights, but your basic outlets, computers, 2-pole devices. But for your lighting, your heavy load, you're running 277 to reduce the energy costs. But when you have a panel box like this, you have to, caution. Lines 1 and 2, line 20 volts, line 3, 277. You have to label that on the outside of the panel. Because if you open up that panel and that's not labeled, you're going to assume that all 3 of these are going to be 120. And you can just be erroneously hooking up like an outlet to 277 And do you think that desktop is gonna take too well if I hook that right up to 277? No, it's probably gonna fucking explode. So that's why we have to clearly label, and that's also the reason for a high leg situation. Any questions on this? No? Cool. We're turning and burning. All right, where are we leaving off? Where are we off?
Those identification of burn circuits and feeders. 267.
Let's take identify the source on 268. Who's up there? Who we got? Who we got?
All switchboards and panel boards supplied by a feeder and other than one or and two family dwellings are required to be marked as to where the power supply originates. See NEC 408.4B. Also see table 12.1. The marking can be combined with other markings such as the panel board, circuit directory. Others may attach phenolic label to the panel board cover.
Oh yeah, I don't even know what that word is. But yeah, you just want to identify the source, and it makes sense. In like a single dwelling or a two dwelling family, or like a residence, it's gonna be pretty obvious where that power is coming from. It's gonna be on the side of your freaking house. You know what I mean? But in a commercial facility, that power could originate from anywhere. You just want to label. You know, it's common to see like panel box PAB1, and then see PAB2. And if you go inside there, it will tell you in the electrical room they are located. You go in the electrical room, and right next to like a big 200 amp breaker, you'll see PAB1, PAB2. They just have to all be clearly labeled, so you know when you're killing it here, you know it's dead down there just by what the labeling is. Close unused openings. Yeah.
It seems obvious that there should be no unused openings in panel boards and switches. Sometimes the circuit breaker knockout and the cover of the panel board or conduit knockout is inadvertently removed, leaving an opening for someone or something to enter the panel board and come in contact with live parts. Very hazardous. Unused openings other than those intended for the operation of equipment, those intended for mounting purposes, or those permitted as part of the design for listed equipment shall be closed to afford protection substantially equivalent to wall of the equipment.
Okay. So yeah, that's just common sense. You know what I mean? But that's why a lot of commercial panel boxes are loaded with spares for that reason. You know, like normally when it comes to that cover plate, they're all knocked out and it's full to the gill of spares. You don't use them, great. The space is still occupied. You know what I mean? So in residential panel boxes, you do see this very often actually. People take it out of circuit and never putting the cover back in. Know that if you do take it out, there are plastic covers that can go into the slot of that cover plate that you just tore off. So there are plastic covers for those, just so we know. Okay. Kyle, working space around electrical equipment?
Personnel working on or needing access to electrical equipment are required to have enough room and adequate lighting to safely move around and work on the equipment. This will enable them to perform the required functions such as examining, adjusting, servicing, or maintaining the equipment. Many serious injuries and deaths have occurred as a result of arc blast and electrical shock. Should this occur, the personnel must have enough space to get away safely and quickly from the faulted electrical equipment. NEC 110.26 covers the minimum working space, access, headroom, and lighting requirements for electrical equipment such as switchboards, panel boards, and motor control centers operating at 1,000 volts or less that are likely to be examined, adjusted, serviced, or maintained while energized. Although common sense, as well as the OSHA rules and NFPA 70E limit working on energized electrical equipment, sometimes doing so is necessary.
All right, so yeah, when we're in big commercial boxes, you need room to breathe, right? The equipment needs a little bit of room to breathe because it's gonna start building heat. And also you need room to breathe when you're doing work on these, or worst case scenario, shit hits the fan, you need to get out of there quickly. You know what I mean? I can't tell you how many violations I see in pretty much every single fucking building I walk into when it comes to this. Does anybody else see any violations? Anybody else see anything? Bill, have you seen anything regarding this? Did this just pique your eye, your mind? You need room around a panel box? When you walk into Lowe's or Home Depot, what do you always see in front of the panel boxes? Pallets, boxes, garbage cans, bullshit. You know what I mean? These panel boxes should be free and clear of anything and everything other than panel boxes or us working on them. I can't tell you how important that is. I think as we go forward, you're going to see a lot of like 3 foot minimums, and that creeps up to 4 feet. Once again, why would you just do the code minimum? Give yourself 5 fucking feet. If you can make the judgment call about it, give yourself as much room as possible. But like I said before, are you probably going to be determining the location of these huge panel boards? No. They'll probably be predetermined by an engineer who got approval and that got signed off. You're just there to put this panel box right where this drawing says to. So, you know, just know that when you're working around these things, there shouldn't be anything in your way. And if there is, you have the right to go to your employer or to the plant manager or whoever and say, yo, get this fucking shit out of here. I'm not gonna risk my life because you need some place to put your garbage cans or something. You know, that should never even happen. I see it in restaurants, I see it in residential houses too. You go down to the basement and there's a whole pile of stuff stacked in front of that panel box. Well, good thing there was an emergency. You know what I mean? Good thing you didn't have to stumble over all that stuff at 1 o'clock in the morning and hit a breaker. It's just dangerous. So just try to give yourself as much room as humanly possible. Free your area of obstacles. You know what I mean? Make sure that door is even open. You know what I mean? If there's an arc flash that happens, you're gonna be disoriented. You know what I mean? Make sure you have a clear, easy way out. Make sure you know your way out. And if there's multiple exits, make sure you know them. I know it sounds a little crazy, I know it sounds a little overboard, but you never know when the stuff's gonna happen. You best want to be able to figure out how to get out of there if shit hits the fan, because you might not get another chance. I saw Clint, he's the 3rd-year instructor at Local 81. You think, like, you know, he's an instructor, he's the 3rd year, he's the cock of the walk, he knows exactly what he's doing, this man can do no wrong. Well, I saw him almost get fucking killed. Just because a socket dropped between 2 terminals, the room, and this was at the, what's the park there on Kaiser Ave? McDade, the coal mine tour. It was in their big switch room. And that room was white when that went off. Blinding, couldn't see anything. I came around that corner, all I saw was smoke and legs. And I'm thinking, Clint's dead. And I saw his legs move and we dragged him out of there and we got the hell out of there as fast as we could. But, you know what I mean? Know your exits, know your way out, have people around. You know, if you're working in a panel box, call up your buddy. Yo, Bill, I'm working in the panel box. Check in with me in 10 minutes. You know, I can't tell you how serious this is. You only have one opportunity. It's like 8 Mile. You only have one chance. You know what I mean? She thought that was funny. I got a chuckle. That's what I was going for today. All right, I got one. Turns out it just needs a little M&M. That's all. All right, who's up? Working space conditions, sir, or considerations, sir.
When discussing working space, the major concern is access to and escape from the working
Oh
space.
man, I was just talking about that. Oh great, continue.
NEC point 11026 addresses working space about electrical equipment, not generally the room itself. Do not confuse the term working space with room. The concern for safety requires adequate working space around the equipment, which may or may not be the entire room. The diagrams on the following pages show the required working space in front of electrical equipment. If access is needed on the sides and or rear of the electrical equipment, the required space must be provided on the sides and or rear of the equipment.
Okay. And yeah, if you read these, if you take a look at the top here, actually, if you can just read the conditions 1, 2, and 3.
Condition 1, expose live parts on one side of the working space and no live or grounded parts on the other side of the working space, or expose live parts on both sides of the working space that are effectively guarded by insulating materials.
Okay, so figure 1210 says that between 0 and 1,000 volts, 3 feet is the number. Okay, continue, John.
Condition 2, expose live parts on one side of the working space and grounded parts on the other side of the working space. Concrete, brick, or tile walls are considered as grounded.
Okay, and for that condition, then for 150 volts or less, it's gonna be 3 feet. 600 volts and less is gonna be 3.5. 1,000 volts and less, it's gonna be 4 feet. But once again, if you can make these judgment calls, try to give yourself as much room as possible. I don't care if it's 150 volts. Give yourself 4 feet. What's the problem in that? You know, if you have the space, use it. And lastly, sir?
Condition 3, expose live parts on both sides of the working space.
Yeah, and once again, the 150 volts or less is usually gonna be 3 feet. The 600 volts, that ups to 4 feet, and for 1,000 volts or less, it's gonna be 5 feet. Give yourself as much room as you humanly can, though. Please, please, please. Different voltages to ground, different working space requirements. Who wants to read that? Nicole, thank you.
For system voltages of 0 to 150 volts to ground, the minimum depth of working space is 3 feet. An example of this is 208 Y 120 volt
Y
connected
connected.
system in the commercial building discussed in this text, where the voltage to ground is 120 volts. For systems of 150 to 600 volts to ground, the minimum working space requirement varies from 3 to 4 feet, depending upon the condition. An example of this would be a 480 270 volt Y connected system in which the voltage to ground is 277. See figure 1211 and 1212.
And now, just make sure that you know they're not talking about the amount of volts available, like line to line on 480 system, that's 480 volts. But they're just concerned with line to ground, which is always just gonna be one leg to ground. Continue.
A working space for voltages to ground from 601 to 1000 volts has been added to NAC table 110. These distances are illustrated in figures 1210, 1211, and 1212. The commercial building in this book does not have a high voltage service. For systems over 1000 volts to ground, the requirements for working clearances, working spaces, guarding, accessibility, and so on are found in NAC Article 110, Part 3.
Okay. Who wants to talk about depth? Working space depth.
Working space depth. Working space is that space required to provide safe access to and egress from the live parts.
What is egress? Out. Escape. Out. A way out. Egress is a way out. Alright? If you have like you may have heard of egress when it comes to your house, right? If you have a bedroom and a basement, you need 2 ways of egress. You know what I mean? Like usually that's gonna be like the staircase back up to your first floor or the Bilko door to get out. There's gotta be 2 escape ways. Just like if you have a bedroom on a 3rd story, you need proper egress there as well. You know what I mean? Whether it be a window with a porch that you can stand upon until the fire department comes, or whether it be another doorway with another way out of the house, like through like a porch or a patio or something. But that's what they mean by egress. Okay.
Generally, this is in front of the equipment, but it could be on the sides or back, depending upon the design of the equipment. If there is a need to access live parts from the sides and or rear of the equipment, minimum working space shall be provided for those needs as illustrated in figure 1213. All working spaces must allow for the opening of equipment doors and hinged panels to at least a 90-degree position, as shown in figure 12-14. This is usually not a problem for panel boards, motor control centers, and switchboards that have covers that are bolted onto the equipment. Some industrial control equipment is mounted in cabinets that have wide doors for providing access. Working spaces are required to be kept clear and not be used for storage, as illustrated in figure 12-15. Working with space distances are measured from exposed live parts or from the enclosure dead front of panel boards, motor control centers, and switchboards. When this enclosed equipment is opened, live parts will be exposed. See figure 12-16.
Very good, Phil, appreciate it. Kyle, you wanna take working space width?
For equipment with a width equal to or less than 30 inches, as shown in figure 1217, provide a working space with a width of not less than 30 inches. Note that the working space is not required to be centered on the equipment. Of course, the equipment is not required to be centered in the working space. The left edge of the working space can be at the left edge of the equipment or at the right edge, your choice. For equipment with a width greater than 30 inches, as also shown in figure 1217, provide a working space width of not less than the width of the equipment. This space width will enable a person to stand in front of the equipment and not be in contact with the ground object. Note as well that figure 1217 shows working space overlapping. This figure demonstrates working space overlapping in the width as well as the depth. Most electrical inspectors will consider that condition 3 applies when energized parts are across from the other, when working space overlaps as shown.
Yeah, and the spaces can overlap, you know, I mean, typically you're only gonna be working on one piece of equipment at a time, you're not gonna have everything in that room torn apart, because that's just gonna cause more danger than anything. You know what I mean, why would you want 600 volts accessible over here and 480 volts accessible over here? Let's keep it down to one danger, okay? You're only gonna work on one piece of equipment at a time. Unless the building is going up, but if the building is going up, there's generally no power there to begin with, so yeah, everything's open, everything's being run. Once everything is locked down, powered on, you're only gonna work on one major piece of equipment at a time. There's no need to be working on multiple panel boards at a given time. Take heat? Take the heat, sir. Or heat, listen to me, fucking height. Oh my God.
Working space height. Working space height is required not to be less than 6.5 feet for equipment more than 6.5 feet high. The working space height must be at least as high as the equipment. The working space height will enable most people to stand in front of the equipment.
9 times out of 10 when you're in an electrical room, if the rest of the facility has drop ceilings, the electrical room will probably not have a drop ceiling. It'll probably be wide open, like as if there was no drop ceiling here, you'd be able to look right to the ceiling. Because generally there's a lot of conduit either coming up the wall, coming down, turning around that room. So generally that room will have a very high ceiling. Continue.
It is important to note that generally this working space is required to be clear of intrusions, as shown in figure 1218. An imaginary box is created comprising the depth and height of the working space. Intrusions, including the working space, is limited to not more than 6 inch as follow. Equipment that is associated with the electrical installation is mounted above or below the equipment that requires the working space. A meter socket is not permitted to intrude. A meter installed in a meter socket is permitted to intrude. A support structure such as a concrete pad is permitted to intrude.
What they mean intruding just means an object poking into that zone. You know what I mean? And the most important being the meter base. The meter base itself cannot intrude, but when you put the meter in that meter base, it does extend a little further out. They don't count the meter itself, they count the base. Let's go limited access. James?
Requirements have been added to the NEC that covers working space for equipment that is installed in areas or spaces that are referred to as having limited access. Although a definition of limited access has not been added to the NEC, it is clear that this equipment is installed in a space such as above a suspended ceiling. If this equipment that operates at 1000 volts nominal or less to ground, it is likely to require examination, adjustment, servicing, or maintenance while energized. These rules apply. Often this equipment is located in these spaces for functional reasons such as for heating, ventilation, or cooling spaces. The applicable rules include if equipment is
No, don't go through those.
Oh.
Okay. Sir, you want to take entrance to and egress from working spaces?
Access to and egress from refer to the actual working space requirements about electrical equipment, not to the room itself. However, in instances where the electrical equipment is located in a small room, the working space could, in fact, be the entire room. For electrical equipment not considered large, at least one entrance of sufficient area is required to provide access to and egress from the working space. A door is permitted but not required. The NEC does not describe what sufficient area means or provides dimensions for this means of access and egress. The building code may provide dimensions of the means of access to the electrical equipment. See figure 1218.
Okay. Let's go to page 274. Let me, John, personnel doors, please.
NEC 110.26C3 contains requirements for personnel doors that provide access to and egress from the working space about electrical equipment rated 800 amps or more. Note that the ampere rating for these requirements for personnel doors is 800 amperes rather than 1200 amperes for large equipment. It reads, where equipment rated 800 amps or more that contain overcurrent devices, switching devices, or control devices is installed and there is a personnel doors intended for entrance to and egress from the working space less than 25 feet or 7.6 meters from the nearest edge of the working space. The doors shall open in the direction of egress and be equipped with listed panic hardware or listed fire exit hardware.
No, that's not for you to worry about, is like the door, but it is for you to worry about the doors incorrectly placed. You know what I mean? If you're trying to rush out of that room, you should just be able to push that door open and you get the fuck out of there. You know what I mean? If you're trying to open a handle and open that door to you, that has been incorrectly put in and that could kill you. You know what I mean? Like I said, if you get involved in an arc flash situation and you happen to survive, you know what I mean? You're probably gonna be on fire. You're probably not gonna be able to see anything. You're probably not gonna be able to hear anything. You're gonna be going out of there with just your hands. You know what I mean? And you don't want a door put in incorrectly to kill you. You know what I mean? You wanna be able to push that door and you get the hell out of there. Once again, it should be free of any debris. It should be free of any clutter, garbage, nothing. There should be nothing in your way. You should have complete and utter egress out of that room at all times. If you don't have it, don't work on it. Who wants to do illumination, sir?
For safety reasons, NEC 110.26D requires that illumination be provided for all working spaces around electrical equipment. This could be the general illumination in the room where the equipment is located, or it might be dedicated illumination. Control for all the illumination for the working space is not permitted to be by automatic systems only. Some portion of the illumination is required to be a manual means to turn on the illumination.
Can you imagine if there was a motion sensor in that room and you were working on a live panel box and you weren't moving much and the lights turned out? Now your hands are in a live panel box. You need to get your hands out of there and wave them in order for the lights to turn back on. And you're going to trust yourself that you're not going to strike any live components coming out of there on your way out to wave? No. Let's have that just be on a switch. Or even better, constantly fucking on. I want those lights on 24 hours a day. It's a 25 by 25 foot room. You can suck up that electrical bill. All right? It's got to be on like a manual switch or constantly on. Continue. Sorry for interruption.
In the commercial building, the service equipment is located outside where illumination is not required. The panel boards located inside the building are in normally illuminated spaces, so additional dedicated illumination is not required.
I'm happy. Any questions, guys? We covered a lot of good concepts today. Please, have the big thing from this class be the location of the 2-pole and 3-pole breakers. It's a pretty important one, please remember that. And please remember egress from those spaces. There's been horror stories of many guys meeting their doom just because of something stupid, you know, like a mislabeled component, right? Not having proper egress, not having proper lighting, not having proper space. And, you know, you don't want your tombstone to read, should have been 3.5 feet. You know what I mean? Like, no, you want plenty of room, plenty of safety. Any questions? Get out of here.